Hi Year 8, here's our second lesson for Pythagoras' theorem. In this video we're going to learn how to find the length of the hypotenuse. In our last lesson we learnt what a hypotenuse is, and we also learnt about Pythagoras' theorem, which is the square of the hypotenuse is equal to the sum of the squares of the two shorter sides. So now let's see if we can find the length of an unknown side, and we're going to put a pronumeral here on the hypotenuse. So the first thing we're going to do is write Pythagoras' theorem for this triangle, which is going to be x squared is equal to 3 squared plus 4 squared. Remember, order is not important here. Now our next line is to work these two out. So 3 squared is 9 and 4 squared is 16. Now we're going to add those two together. 9 plus 16 is 25. So we're left with x squared is equal to 25. Now that's obviously not the answer because 25 is too long for this side. That's because it's x squared. Do you remember how to solve a quadratic equation? How do we get rid of this squared? We do the square root of both sides. Do you remember? So x is equal to the square root of 25, which is 5. So there's our answer. The length of this hypotenuse is 5. Now hopefully you're saying to me, but hang on, you said that when we solve quadratic equations like x squared equals 25, we get two answers. X squared equals 25, do the square root of both sides. X could be plus 5 or minus 5. But here's the thing, does the answer x equals negative 5 make any sense as the length of a side in a triangle? It doesn't, does it? And this happens over and over again in mathematics. Theoretically, we have two answers, plus or minus 5, but in real life, there's only one. Lengths can't be negative. We only need to give the positive answer. So let's do another one. Find the length of the unknown side, y. So let's start by writing Pythagoras' theorem. We'll find the hypotenuse, it's y. Y squared is equal to 5 squared plus 12 squared. Now let's work these out. 5 squared is 25 and 12 squared is 144. Add them up. Gives us 169. Y squared is equal to 169. We need to do the square root. So y is equal to the square root of 169, which is 13. Now the answers aren't always going to be nice whole numbers. Sometimes we're going to get a whole string of decimals. And in these cases, what we do is approximate our answers to 1 or 2 decimal places. Now, as a general rule, if you're not told how many decimal places to do, choose one more than what's in the question. So there's no decimal places here, so I'm going to approximate to 1 decimal place. But let's start by writing Pythagoras' theorem for this triangle. X squared equals 5 squared plus 10 squared. Let's work these out. 5 squared is 25, 10 squared is 100. Now let's add them together, 125. And then we're going to do the square root. So x is equal to the square root of 125, which is not a nice number. If you put in the calculator, we get 11.180333989. We don't want to write all of this. So we're just going to chop it off here, but we must round. So have a look here. We want to chop here. Have a look at the next digit. It's too big to throw away, it's greater than 5, so we're going to have to round up. So x is approximately equal to 11.2. Let's do one more. If the question has units of measurement in it, like this one, you see the centimetres? Include them in your final answer, don't put them all the way through when you're working out. Alright, we want to find the length of the hypotenuse. Have you noticed there's something missing? There's no pronumeral. So let's just make one up. We'll call it x. Let's write Pythagoras' theorem. X squared equals 10 squared plus 8 squared. Now working those out, we're going to get 100 plus 64. And adding them together, we get 164. Now we're going to do the square root. Square root of 164 is not a nice number. When I do it on the calculator, I get 12.80624847. So we're going to approximate it to 1 decimal place, 12.8 centimetres. Now of course Pythagoras' theorem can be used in real life to find the lengths of unknown sides in a right-angled triangle. So here's a practical problem. Andrew builds a gate of length 2.1 metres and height 1.4 meters. What is the length of the diagonal? So we can see that this is a right-angled triangle in here, and we're told that the length here is 2.1 and the height is 1.4. And we want the length of the diagonal, which is this brace here. So we're just going to use Pythagoras' theorem. X squared is equal to 2.1 squared plus 1.4 squared. Working these out, we get 4.41 plus 1.96, which is 6.37. And then finally doing the square root, x is equal to square root of 6.37, which is 2.5 meters. You can see how I've included the units, and I've only gone to one decimal place to match the dimensions given in the question. Now I want to finish this video by talking about working out. You must include sufficient lines of working out. It's essential that you communicate your logic to the reader. I know that you can do this straight out on your calculator. I can do that too, but I'm not communicating my reasoning. Most teachers will want 5 lines of working out. You can probably get away with 3, but that's the minimum. Let's have a look. Same question. X squared is equal to 10 squared plus 8 squared. You have to state Pythagoras' theorem. Then I know you can do 10 squared plus 8 squared on your calculator. That gives you 164. You need to show the step from x squared through to x. And then you work out the square root of 164, which is 12.8 centimeters. The other thing I want to say is this is really important, and a lot of students get this wrong. They leave this x out, or they continue to call it x squared. So just be mindful of that. As soon as we do the square root, we've got to write x, not x squared. Okay, that's it for this video. Now next video we're going to look at how to find the length of a short side in a right-angled triangle.